Hello everyone, so in this video, let's talk about the first four problems from the latest AtCoder beginner contest 395. So let's start. The first problem is pretty much very simple. It says that you have to find out strictly increasing sequence. You are given a positive integer n and a sequence of positive integers a1 to an of length n. Determine whether a is strictly increasing. So you are given series of numbers. You just have to tell that they should be strictly increasing, which means that the next number should be greater than the previous number, not equal, just greater than. So you just have to just do a for loop over whole of this. Just check that the current number is greater than the previous number. If it is, then the answer is yes for every number possible, else the answer is no. Okay, so if you just go to the code, it's pretty much very simple. I can show you. What we have done is that we have iterated over all the numbers from the index 1 to all to the n, and we're just comparing I and I minus 1, the previous number. If the current number I am on is greater than the previous number, then it is fine, we can continue. Else the answer is no, and we should return that this is the answer, that no, the sequence is not strictly increasing. Okay, pretty much simple, nothing much difficult here itself. The next is make target. So as you can see that you are given that you have to form an n cross n pattern given like this. Okay, now what this pattern is all about, that you are given some possibilities n. Now consider n cross n as the grid. Let ij denotes the cell at the ith row from the top and jth column from the left. So ij denotes some ith ij coordinate in this particular grid. Now no cell is colored. Initially no cell is colored. Now for I from 1 till n, for all the n numbers in order, perform the following operation. If let j is equal to n plus 1 minus I. What you can understand from here? See, if I is equal to 1, j is n plus I minus 1, which means that 1 is the very top element. Like if 1 is the very start and the other is the very end, because it's a n by n grid. So n plus 1 minus 1 is just the last element. Okay, because if we take 1 minus 1, so this 1 and 1 cancel, it becomes n. So from 1 till n, so it's denoting the two extremes. So if I is 1, j is this other extreme. So if I is less than j, fill the rectangle region from I comma I to j comma j. So I is the very top and j is the very bottom. So I comma I is this, j comma j is this. I comma I. So you will fill it if I is odd. So with black if I is odd, and white with if I is even. So if I is odd, you will like fill like this, like in this particular manner, in this block manner. If I is even, like fill these dots. Okay, so this is what this whole thing is, that you have to make these types of like you can say rectangles inside a rectangle and so on. So what you can see here is how you can do that. There can be multiple ways to solve it. Because the constraints are pretty much small, what I thought is that I'll draw it out so that it becomes more clear. Let's take an example that I have nothing initially. Okay, so nothing as in like the first element is hashes. So let's assume that all the things are initialized with hashes. Okay, let's assume that we have hashes like this. We just make an n by n grid. Let's assume 5 by 5. So 5 n by 5. Something like this. So we have the whole grid make with hashes 5. You can assume that there is hashes in between them also. Okay, so what you can do is that what I can just think in this moment is ki we just have to make rectangles. It's just like if you have seen that a cookery class, if in a cooking class, what you can see is that if I want to make, if I want this whole thing as hashes, like the outer dimension, this as a whole hash, I can use a different color. If I want this as the whole hashes and the inner one as different color, I can first initialize this with whole hash. Then I can make the inner rectangle whole dots. Okay, so I can make a function that can take the very starting point of the rectangle and the end point of the rectangle. These are squares only, but yeah. So, and it will color all of them in dots, whatever like symbol I will give. So let's assume first I will take the outer square and fill it with hashes. So everything will be hash. Okay. Then I will give this extreme, this, and fill everything with dots. So dot, 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 dot. Then I will come down to this, and I will make everything hash. So it's hash. So it means that we are like doing it slice by slice. So the outermost layer is first, like the whole rectangle is first, make it like hash, inner rectangle, then is dot, and more inner will be hash, more inner will dot, and I will do it for every rectangle possible or like square possible. So in the end, I will have this particular pattern. I hope you understand what I'm trying to say here. That is what we are trying to do here. So let's try to now see it by the code. It's not much but difficult here. What we have done is that we have taken n as input. Okay, whatever is the length of the n cross n grid that you want to form. This is, as you can see, is the n cross n grid. I have initialized it with hash. Now I will do a for loop for every element from I equal to 0 to I equal to n, and I will go it to the till the very middle. So 2 into I. So it's like I have to go to the n by 2. So if I want to go to n by 2, I will go into 2 into I less than equal to n. It's just like take not dividing it by 2, but like I have to make it I less than equal to like I less than n. Okay, so like I can take this multiply it here. I less like I is less than n, but it can also become equal. So yeah, I is less than equal to n. I can take this condition as well. And then if it is even, I will make it hash. For odd, I will make it dot. And this color function will color the grid starting from this I comma I till n minus like n plus 1 minus I. Okay, that is what this color function will do, like coloring the squares from the very top to the very middle, then another smaller square, and this I will keep on changing from this for loop. Okay, and then we have the whole grid that will print it out. Now let us see how this color function will work. This color function will start and will get the, so s of x comma y, this is the very start of the square, and e of x comma e of y, so start xy end xy, it will denote the square. And I will just do a for loop from like I like s of x to e of x, and nested like s of y e of y, just like us like just iterating over every element in this particular square and making it to the character that I'm sending. So it's just like coloring this whole square given the character I want to color. So initial I will first color like hash, and the inner like square I will color like dot, and hash dot and so on. So it will just become the pattern that you have seen. Okay, nothing much difficult here as well. Just understanding that there can be multiple ways, but I've chosen this way. Okay. The next says that shortest duplicate subarray. So you are given an integer n, an integer sequence a of length n. So it's a very standard problem. You are given integers a of length n. Okay. Determine whether there exists a non-empty subarray of a that has a repeated value occurring multiple times. So you have to find out that whether in this sequence of numbers there exists a continuous subarray that has a repeated value, like a value that is here, it can also be repeated here or here. If there exists such subarray, find the length of the shortest of such subarrays. So let's assume there is 2, 3, and then 4, and then 2. So this 2 and 2 appear. So this is the shortest subarray. Maybe I'm just giving an example that has the same number occurs multiple times. Okay, you just have to find out the one. So it's pretty much simple that you have to iterate over every number, store the occurrence of this number, and whenever I get another number, I will check that whether I've seen this number again previously. If I've seen this number previously, which means that this has occurred again, so I can form a subarray between this and this. So wherever I have seen this number last time, I have to take that. Wherever the latest I have seen this number, I will make a map of the number I have seen last and the current number I'm on. The difference between them, I will find out the length of it, what is the subarray. I will just try to minimize as possible. And if there is no repeating number, then the answer will be negative. Okay, nothing much difficult. I think so. It's a very standard problem. Let's move on to the code part to make it more handleable. So what we have done is that we have taken the input n, the whole numbers, the numbers itself. Then I've initialized the number with a very large number because we want to minimize the answer. So I've initialized with a very large number. Take a map, iterate over all the possible numbers. Check that I have seen this number or not. If I have not seen this number, if the number doesn't exist in the map, which means that I am counting that whether this number exists in the map. If it doesn't exist, which means that the count of it is 0, I will add in the map. The number is mapped to the index where this number exists. So let's assume I have seen, so let's say I have numbers like this 2, 3, 4, and 2. So I have first seen 2, which is at index 0. So I will map the number that is a of I, which is 2, to its index. Index is this index that I'm iterating over. So index is 0. So I will map 2 that I've seen 2 at index 0. So I will make a map of the number to its index value where it exists in the array. Okay. Then if I have not seen this number previously, I will keep on updating this index. If I've seen, let's assume, then I will add in the map that, okay, 3 is existing at index 1, 4 exists at index 2. Now, when I come to 2 again, I can see that, okay, 2 already exists. So 2 already exists at index 0. So if it already exists at index 0, I am at index 3. So 3 is there, index 0 is there. So how many elements are there in between? So the number of elements is 4 because I have to take all these elements. So the sub-array length is 3 minus the index, I've already seen it. So 3 minus 0 plus 1, the length of the sub-array. Okay, so this is the current index I'm on, I minus the index the previous occurrences plus 1. This will give me the length of the sub-array. So I have to minimize this. That is what we have done, and that's it. That is what we have done. In the end, if I have not seen this, like if there is no occurrences or no repetition of any number of any sort, then what will eventually end up happening is that the answer will not change. If the answer will not change, which means that this should be -1, or else if we got the answer is there. Okay, that is the overall simple solution of it. Now let's move on to the next question, and that is the one, it's a good question. Okay, let's focus on the implementation first, and then we'll talk about the solution. The solution will come very easily if you understand the what we are trying to do. So there are things is that there are n pigeons labeled from 1 till n, and there are n nest. Okay, so let's assume there are pigeon 1, pigeon 2, pigeon 3, and pigeon 4, and there are nest 1, nest 2, nest 3, nest 4. Okay, now initially pigeon I is in nest I. So let's assume pigeon I is in nest, like ith is in nest I. So pigeon 1 is nest 1, pigeon 2 nest 2, pigeon 3 nest 3, pigeon 4 nest 4. Okay, you can perform queue operations on these pigeons, and you have to perform queue operations, and the operations are of 3 types. These are the 3 types of operations I can do. Type 1, you are given integer a and b. Take pigeon a out of its current nest and move it to nest b. So let's assume I want given some operation of type 1 that take pigeon 1 and move it to nest 3. So currently the pigeon 1 is at nest 1. So I have to move it to nest 3. So let's just erase this out. Let's assume I want to move the pigeon from nest 1 to nest 3. Okay, so I can just move the pigeons like them. So a single nest can have multiple pigeons as well. So as you can see that these 2 pigeons reside in the same nest. Okay, type 2. Now the type 2 operation is that you are given integer a and b, move all the pigeons in nest a to nest b, and move all the pigeons from nest b to nest a. So I have to move all the pigeons. Let's assume I have to now move the pigeons in nest 3 to nest 1, and all the pigeons in nest 1 to nest 3. Or maybe let's do it for these 2. If I want to move all the pigeons from nest 3 to nest 2, and all the pigeons in nest 2 to nest 3. Now these 2 pigeons reside in nest 3, so I have to point it towards this and this towards this. So as you can see here, I have to now point all these things, all these different pigeons which are there, to a different nest, and similarly all the pigeons on this nest point to different nest. So it's a highly time consuming process to take all the pigeons and like move it to different nest. Okay, and then the last one is for a pigeon a reports the label of a nest it's currently in. So let's assume I ask that where the pigeon 1 resides in nest 3, where the pigeon 4 resides nest 4. So you have to now do all these 3 type operations. These are the constraints. Constraints are pretty high. So you have to report all these answers. Now, if, as you can see, let's jump to the, so if I hope you understand the problem statement. You have three type of operations. You are given some queries. In the third query only, you have to return uh, the pigeon location. Okay. The other is just moving these pigeons around in the nest. And you just have to tell what is the final positions of the pigeons in query 3. If I try to do the same thing that I've drawn, the operation 1 is simple because I can just move, I can just make a array of locations of pigeon, that what are the p1, p2, p3, where the pigeons are residing in. And if I want to make p1 go to n3, p1, p2 go somewhere, I can directly just do it in one change. But this change of type 2, it's time consuming because I have to move all the pigeons which are residing in N3 to N2 and N2 to N3. So that is time consuming. So how can we optimize this operation? Okay, so let's erase this out and just try to draw it in a very fresh manner so that it becomes very clear. So P1, P2, P3, P4 are the pigeons. And then let's assume N1, N2, N3, N4. This resides here, this resides here, this resides here, this resides here. Now let's assume I want to move some pigeon. This pigeon moves to this position. Type 1 operation is simple. Now if I want to move this pigeon, both of these pigeons in N3 to N2 and N2 to N1, it's a time consuming process. So what's the catch here? The catch here is that I am actually moving this N3 to N2 and N2 to N3. So I'm just swapping these nests, okay? And swapping of this nest is actually swapping all these pigeons. So that is time consuming. So what you can see is that if I just swap one pigeon, if I just swap one pigeon out, like swapping one pigeon from P1 to P3, it's simple. It's just O of 1, just swapping this to this. So why not also group these pigeons into one more abstraction layer? So what now we will do is that we will add an abstraction layer in front of it. Let's assume we name it now groups G1, G2, G3, G4. So now just assume that P1 belongs to a group G and this G group sits in nest to N. Okay, P2 pigeon is of group 2 and resides in N2. Similarly, so this just means that these are like groups, like friends, you can just say. So all the friends are residing in N3. Now, instead of moving P1 to N2 directly, if I want to like do this, that I want to like now move P1 to nest 3. If I want to now move P1 to nest 3, instead of directly doing that, why not point this to the group itself? Now, if I want to find out where a certain pigeon resides, I can directly just go down this path. That okay, P1 belongs to G3 group and G3 group is in nest 3. And P3 belongs to group 3 and again group 3 is in nest 3. So this change is again one step because like O of 1 operation to just change the group. And similarly, now if I want to swap that all the pigeons in nest 3 should be belong to nest 2 and nest 2 to nest 3. So all the pigeons means all the pigeons of group 3 because all the pigeons are now acting as a single entity, that is group, this a single group. So why not just move this group here and this group here, because this is like a single group. Instead of like moving all of them, why not just move this group here? And that makes it very much simple, that adding an abstraction here makes it very simple, that now if I just want to bring all the pigeons from which are residing in N3 nest, I want to move it to N2 nest, I can just point this group to N2 and this group to here. Which means that now instead of like moving these things, I can just add an abstraction layer. That is what the benefit of abstraction layer is, that instead of like taking and moving all of them, I've just added an abstraction layer of groups. And then these groups help us to move around between these pigeons and nest, because these are also acting as single entity, and as we have seen, pointing a single entity to different things is O of an operation. So I hope you understand what I'm trying to do here is that just moving these entities around is difficult. So just make an abstraction of groups and just move these single groups around. Okay, so this is what we have to now try to do. Now, how to write the code for it? So now we have to add one more abstraction, let that is group. So now we have to have a pigeon to group mapping. So we have to have a pigeon to group mapping, that is P2G. We have to have a group to nest mapping, and also let's assume that I have to have group to nest mapping, but let's assume that we want to now move two things. Let's assume I want to swap nest n2 to n3. I want to swap, because in the query 2 I am given that I have to swap nest all the pigeons in nest 2 and nest 3. So pigeons in nest 2 and nest 3 means that I want to swap the groups. So I have to also have a reverse mapping, that which group is now mapping to which, like which nest is mapping to which group as well. So that I can like, because in the end I'm given pigeon and nest, I'm not given group. So I have to have a pigeon to group mapping, and also as you can see, group to nest mapping and nest to group mapping also, because then when I'm giving that I want to move to nest, I have to know that which group it is mapped to, so that I can directly move that as well. So I have to also have nest to group mapping. So these are three mappings I have to make, and then accordingly I have to just swap all of them depending on the conditions, and that's it. Okay, let's move on to the code part now to make it more understandable. Okay, so we have n and q as input. Okay, we have the group to pigeon mapping, the pigeon to group mapping, and the pigeons. Okay, pigeons is like just I can say that this pigeons is the top layer. Then where this pigeon, so this pigeons is like pigeon to group mapping. This is like pigeons to which group is mapping to. This pigeon to group is like understanding like there is a mapping between pigeons and the group itself, and then group to the pigeon. So it's just like the three groups I've told you. You can just name it whatever you want. And then these are three things that you have to do when you are just manipulating your pigeons. So you are manipulating that which pigeon, so you have to change the group. Okay, when you are like updating that I have to move a pigeon, the first step of operation is that I want to move a pigeon from group wherever it is to nest B. So we have to first find out where nest B is. So nest B is, so we have to, instead of like changing for the nest, we have to now change the groups. So we are given pigeons. I have to move the pigeon to this nest, certain nest. So if I want to move to a pigeon to a certain nest, I don't have to move to the nest. I have to go to the group. So I have to have the reverse mapping, that where this like a nest to the group mapping. So I have to get that, and then I have to just move my pigeon to particular group. That is done here. In the type 2, I have to swap to nest and the two groups. So I'm swapping both of them here. So I have to, because it's bidirectional graph, I have to swap both like this. So maybe I have to first swap these two values and these two values itself. And then if I want to get the final output, the output is that I want to get for a particular pigeon. So I have to first get the group from the pigeon, and then I have to get from that group the particular nest it resides to. Okay, so group to pigeon, from the pigeon I will get what group it resides to. This will get from here, and then after I get the group, I will get to where the group leads to, which nest is there and which I can get. I have the naming convention is still not very correct for me, but yeah, you have to take three arrays, and I have told you what's the complete logic of it, and you can do that around. Okay, that's the complete logic and code for the first four problems of the AtCoder video 395. If you still have any problems, you can mention in the comment box. Thank you for watching the video till the end. I will see you next one. Keep coding, and bye.